Okay, so hey Comets, welcome to Algebra 2. It is Saturday the 19th, and we are about ready to get started on this. Now, all I'm doing today is I'm doing the review sheet that Coach Emmons sent to me. I'm not doing anything special, different, or unique. So if you have the review sheet, hopefully from your teacher already, you can go ahead and pull that up. It's called Interim Review. Let me see, I can show you. It looks like this coming up. And then what's going to end up happening is I've separated a lot of the questions out so I can kind of teach you as you go. Here is my disclaimer. I have not done Algebra 2 for a long time. So I am about 98% confident in all of my answers, but I might screw up. So if that's the case, I'm sorry, but hopefully you will at least feel more confident than you feel already. So this document right here, I have put on to GwinnettMath.com. Right now, because I'm managing three things because I love you guys, I'm doing Algebra 1, Geometry, and Algebra 2. So even though we normally have our YouTube channel, that still will be where I end up putting everything. However, to keep it more organized, I'm going to put stuff into GwinnettMath.com. So if you go here first, then you'll have the updates. So like after today, this big mega math thing will disappear. But then because you guys are Algebra 2, you'll just scroll down. So my most recent video that I did with you guys was functions. So that's why you see the functions video up. And then I haven't figured out if I'm going to have it spin like a wheel or how I'm going to do it. But pretty much this is the source to go. So if you don't have the review sheet I just showed you, it's available right here by clicking that little button, and then you can print it out. Of course, use paper. Next, please take notes. And I love that it's Algebra 2 because you guys had me last year. So right now your mics are muted. That's one benefit from Google Meet, is that instead of you having to type your questions, you can just unmute your microphone and speak your question. So anytime, same process that we've done before. If you have any questions, just unmute your microphone, ask your question. Of course, you can still type. You don't have to, but please do that. If you notice, people already have gone in and they have put their name and their teachers. That's their teacher's name. That will allow me, when we're done with all of everything, I'm just going to take this information and I'm going to send it out to the Algebra 2 team so they know who signed on and participated live. Okay, so this is what we're going through. And like I said, I've done everything except the back, but I've already worked it all out once, so I didn't look like a complete fool helping you. And then we'll go from there. And again, as you know, growth mindset, if you think I'm doing something wrong, please tell me. Put on the mic and say, Doc, we learned it differently, or that doesn't seem right, because again, I'm doing the best that I can do. So just make sure your cameras are off. Otherwise, everyone can see you, and then we'll get started. Okay, so first things first, let's talk about the first thing that your test is on. The main things that she wanted to make sure that we covered was AKS 9. That was addition, subtraction, and multiplication of polynomials. You also need to know how to do long division and synthetic division, or synthetic division. That's going to be the last thing on this review packet. You need to know how to solve quadratic equations by factoring, by taking the square roots, by using the quadratic formula. And she put CTS, completing the square. You need to know how to compose functions, including finding the inverse. You need to know how to do conjugates of imaginary numbers. And I know those who I've had before, you know what I'm talking about, the imaginary numbers. You should know that now. And then writing the function. The next thing that she had on this review sheet was knowing the different AKS. So as a reminder, some tips that she has is when you go over and do adding, make sure that you're combining like terms, knowing that x squared and x are two different things, so you won't be able to combine those. When you subtract, make sure you distribute the negative to each one of the terms. By multiplication, you can either use FOIL or you can use the box method. Long division, there's two different types you guys have learned. You've learned long division and you've learned synthetic division. I do know one of the teachers, a couple of the problems he showed you or she showed you were a little off. So with synthetic division, the main thing is that remember to change the sign of what's called the divisor, what we're dividing by. But then it talks about rewriting it, doing the long one. Next, you should have seen this. Completing the square. We did completing the square a lot. That was one of the questions if you had me for geometry last year that we did awesome on. That's the one where we had the divide by 2 going down, square going up, divide by 2, square going up. That's all completing the square is. So you guys really killed that. This one is a quadratic formula. We're going to be singing today because that's how I remember it. I believe it's on your formula sheet, but we'll talk about that. And then also you learn composite functions. If you're not very good at functions, that is the video that I already did for you a couple weeks ago. That's like the f of x and g of x. So some of the things to remember is that the order that they do it is really important. Inverse is when you switch the x and y and you solve. Honestly, I don't know what she means by this. So when we get to this part where it talks, if you compose a function and it's inverse, then you know that they are inverses if they equal y equals x. I have no idea what that means. So you guys can tell me what that means when we get to it. Finding the conjugate, which conjugate is just a fancy way for saying opposite. And then writing a function that describes a relationship. All right, so we're going to go ahead and get started. Of course, you have your pencils out, you have your papers out. Hopefully you have this packet out so you don't got to do it twice. Again, if you have questions, please ask. If you think I'm doing something wrong, please tell me, because it's definitely quite possible. We've had about 4 more people sign on since when I first started. So if you have signed on and you have yet to put in your name and your teacher in the chat box, please go ahead and do that. And of course, ask questions whenever you want is totally fine. Why am I not getting my add pen? This all of a sudden did not become fun. Last time, like literally the presentation I just did for Algebra 1, I have all this writing going on. I don't know why my pens are not up. Let me try one more time and see what happened. And then if not, I can always use Epic Pen, but I don't know why it's not letting me do it. And now it's not responding. That's good. Okay, let me type in Epic Pen just in case we have to do that. What I liked about doing it in PowerPoint is that it lets me save all of the notations. And then by saving it, you guys can look at it later. Ooh, wow, this is not good at all. Okay. Oh, let's see. Did it do something? It did do something. It closed out. Let's try again. Man, I thought I was all set. There's my pens. Yay. Okay. All right, here we go. So going ahead to get started, this is functions. We've already talked about functions if you watched the previous video. If not, that's totally fine. Let me go ahead and save this to the cloud before I even get started. That way hopefully we won't have the same problem before. Or it could be Freddie's playing. I'm sorry. Anyway, with functions. Functions are, to me, are one of the easiest things that you're going to do in Algebra 2. The reason why I think it's so easy is all you're doing is pretty much adding, subtracting, or multiplying trinomials and binomials. So let's take a look here. Here how it says f plus g and then the x, all that means is you add up the 2 functions. So when I did mine, for me, it was easier to just write one on top of the other. Now, the only thing that kids get wrong when they do that is really for subtraction. When you do subtraction, you want to make sure that you end up changing the signs, and I'm going to show you that for letter B. So when I do addition, some of you are like super quick and you'll just be able to combine like terms in a row. For me, it's way easier to go ahead and line everything up. Now, when I line everything up, I make sure that when I line it up, the common terms are underneath each other. So what I mean by that is here I have x squared, so here I have x squared. Here I have x, here I have x, and then I have my constants. That way, it's a lot easier for me to just add going down. So 2 of you guys have your cameras on, which is totally fine, but that means all of us can see you. So you should see like a little box toward the bottom of your screen that you'll be able to like turn the camera off. Okay, so then I just add going down. 5 plus 4 is 9, so I've got 9x squared. You are welcome to have your camera on if you want, but you don't have to. Here I've got the -2 plus 7, so that's going to leave me the positive 5x. And then I've got the 3 minus 5, and that's just going to give me -2. So that's the problem. It's literally as simple as adding up the common terms, and I just think like old school math, and I just add going down. For the subtraction, it's a little bit different. So for the subtraction, I'm still going to start with my same equation. It says f minus g, so the f is going to go first. So I'm still going to write my 5x squared minus 2x plus 3. And then when I write my g, I still am going to write my 4x squared plus 7x minus 5. What's different is I'm subtracting the entire trinomial. So because this is subtraction, I'm going to write a subtraction here. But it's really hard to remember to subtract everything. So what I do is when I write it in this vertical method and lining up the common terms, I then turn everything into the opposite signs. Because really, when we distribute the negative, that's all we're doing is changing the signs. So this subtraction becomes positive, which makes this negative, which makes this negative, which makes this positive. So you don't have to do it this way. Some of you would just on your paper automatically think to change the signs this way. That's totally fine. Just for me, it's easier to write it one on top of the other, and then I change the signs going across. Now I can just add going down. So I've got 5 minus 4, which is 1. I'm not going to write the 1, so I'm just going to have my x squared. I've got negative 2 and negative 7, which leaves me with negative 9, and the x just drops down. And then I've got the 3 plus 5, which is 8, and the problem is done. So I just like to do the put it on 1 on top, change the signs, and then make it work. The next one is a little bit different. The next one, because it doesn't have everything in x, it says that it wants you to solve it, but it wants you to solve it in terms of 0. So what I do is I first say, okay, well, if this is g minus f, and then I have the 0, I write it like this. I say, okay, Michelle or Doc, what's g of 0 minus f of 0? So because I know you guys like to communicate, so right now, all I need you to do is take 0 and plug it into the equation, okay? Plug 0 into each of these and then tell me what you get. And you can either tell me what you get by putting your mic live, or you can type it in the chat. No one's typing or saying anything. Okay, so just in case you don't remember how to do it, let me show you. All we're going to do is, and I do this one kind of quick. I definitely use a hack for this. Because I see so many things are being multiplied, I just know that, let me just close Epic Pen out because we no longer need it. I just know that I, in essence, can cross out the first 2 terms. So when I go here, what I'm going to do is I'm just going to put 0 in here. Well, I know anything times 0 is going to be 0. So this first term, I don't even care about. When I plug 0 into here, I know anything times 0 is 0, so I don't care about that. So really, I'm left with 0 minus 5. That's going to be my g of 0, is negative 5. The same thing is what I'm going to do for f. So I'm going to put 0 into here. Well, 0 squared is 0. 5 times 0 is 0. I'll put 0 in for here. Negative 2 times 0 is 0. And then I've got my plus 3. So 0 minus 0, 0, plus 3 leaves me with positive 3. So that's what I've done for g of 0 and f of 0, is simply just substituting it in and see what I get. Now, because I have to subtract it, all I'm taking is negative 5 and I'm subtracting 3. So negative 5 minus 3 is going to leave me with negative 8. And that's my solution. So to recap, whenever we're doing things that deal with functions, if it's x, that's when you're going to have to do some math. So like in A and B, it was like of x. So I had to kind of do my math to go along, and then it's kind of substituted in. I'm just combining like terms. When they give it to you, or they give it to you of a number, you need to substitute that number back into each of the equations and then do whatever the step is. In this case, it's subtraction. So I'm substituting the 0 in. I'm solving each of it. I got negative 5 and positive 3, and then I combine them. Okay, let's look at another one. Now they want us to do multiplication. So they tell us f of x is 5x squared, and they tell us that g of x is 3x minus 1. So all this is multiplication. So I'm going to write my 5x squared. And because it says this is a binomial, I'm going to put the binomial in parentheses. And then I stop. Now, to solve it, some kids get screwed up here because they think there has to be an equal sign. You don't have equal signs when you do functions like this. Pretty much what you're doing is you're just substituting and not really solving, but simplifying. And so there's no equal sign. There's no like do something to both sides. It's just basic the math principles. Now, I will say, don't forget that when you do the distribution here, you are going to need to make sure that you do the distribution to the 3x and you do the distribution to the -1. So here, how I've got 5x squared times 3x, I'm going to pretend you never learned this at all. So some of you will be like, Doc, you're going too slow. Some of you will be like, you're going just right. So I'm going to pretend you never learned this and teach it like that. Here, this is saying 5x squared times 3x for the first term. And then it's saying 5x squared times -1 for the second term. Once I've done that, then I can just simplify and I can be like, okay, well, 5 times 3 is 15. And then whenever I multiply, I'm really adding exponents because this is really saying 5 times x times 3 times x. So I'm really just adding what's 2 plus 1. And so this is going to give me x cubed. Then here I've got 5x squared times -1. So 5 times -1 is -5. And then the x squared is just there. And that's it. That's the whole problem. You don't set it equal to 0. You don't say x equals anything. It's just done. All right, here comes the next one. This one's a division. So we're going to put the top divided by, we're going to put f divided by the g. So my f is 5x squared. That's this top part here. And then my g is the bottom, which is 3x minus 1. That's literally the end of the problem. Now, what I don't like about this one is sometimes you would have something where you would need to simplify. So for example, this is like another example I'm making up in my head. Let's say you had f of x was equal to x squared plus 2x plus 1. Yep. And then let's say g of x was equal to x plus 1. Well, what happens is in this case, you would still put the x squared plus 2x plus 1 in the numerator, and you would still put the x plus 1 in the denominator. But what makes you have to look at it one more time is that really x squared plus 2x plus 1 is really, when you factor it, remember factoring from Algebra 1, if you do the box method, you know the x squared goes here, the 1 goes here, and you're trying to get the x and the x to get the 2x. So then you would have gone, oh, this is x plus 1, this is x plus 1. That's the reverse box method. I did that fast because you're going to see it again much slower. So this is really x plus 1 times x plus 1. And then, let me go over, let somebody in. And then all of that gets divided by x plus 1. So because of that, these cancel. And so my full answer would be just x plus 1. Okay? So that is one thing to think about, is sometimes you have to check just to make sure that you don't have to simplify it further. Okay, that's done. All right, let's go on to C. So for letter C, and I do want to keep all my notes, so I'm just going to kind of like draw this little, box this off so people don't get completely confused by what we did. Even though that looks a little bit more complex. Let's look at G. G says, all right, let's multiply these together. Honey, whoever just turned on, you might want to turn off your camera. So you should see like a little toward the bottom of the screen. You'll see like, if you hover, you might see like a little camera key. Yep, you got it. Okay, so all this is saying is we got to multiply together. You might have learned FOIL back in the day to do multiplication, where it was like first, which was 3x times 3x. And then outer, which would have been 3x times -1. Then inner, which would be -1 times 3x. And then last, which would be -1 times -1. You might have learned it that way. A lot of teachers teach FOIL in that method. You might have also learned the box method, which I'm not going to show you right now. So we've got 3 times 3, which is 9. X times x is just x squared because there's 2 x's. Then I've got my 3x times negative 1. So I'm going to just multiply 3 times negative 1 is going to give me negative 3. And then I've got my x. Then I'm going to do my blue, which is negative 1 times positive 3, which is negative 3x. And then I'm going to do my negative 1 times negative 1, which is positive 1. I'm not done yet because I still have to combine those like terms. Because I've got the 3x and the negative 3x here, they both have x as the variable. I'm not going to combine it with x squared because x squared is its own thought. It's like I've got apples, grapes, and oranges. They're all fruit, but I can only combine my grapes. So here, and if that didn't make sense to you, don't worry about it. It doesn't have to make sense. But here I've got my 9 apples, or my 9x squared. Here, I'm going to combine negative 3 plus negative 3 is negative 6 grapes, and then my 1 orange. So this would be the solution to this problem. Okay, and again, if you just signed on, you can go ahead to GwinnettMath.com where you saw the link. You'll see the little box to get this. Okay, before we go on, that is functions. Does anyone have anything else they want me to cover about composite functions? Because I'll be happy to do it. You can put your mic on if you need help. But I don't want to move on until you feel mostly better about functions. Okay, so I guess I'll keep moving on because no one said anything. All right, next. All right, the next thing we're going to talk about is we're going to talk about imaginary numbers. Now, the thing that I never remember the 4 things without doing the math, okay? So this is how I remember what imaginary numbers equal. The only thing I ever remember, and this is probably not good practice as a math teacher, is I always remember that I squared equals negative 1. That's the only thing I always remember. So what I do is on my paper, I write my I squared equals negative 1. I always know that. So then I go backwards. I write my I here, my I cubed, and my I to the 4th. So if I know that I squared is always negative 1, I think, well, I has to equal just I. And the reason why I think of it like that is I think, well, 5 has to equal 5, 800 equals 800, so I is just going to equal I. Okay? Then I think, well, I cubed is really just saying I times I times I, or I times I squared. So to remember for me, I cubed, all I do is, okay, well, what's negative 1 times I? Well, negative 1 times I is negative 1I, but we know good math practice is we don't write the 1. So I cubed has to equal the opposite of I. Okay? And then I to the 4th, well, I to the 4th is the same thing as saying I squared times I squared. So then I think, okay, well, what's negative 1 times negative 1? Positive 1. And that's how I come up with everything. The only thing I ever remember is I squared is negative 1. Then I work back and forth to remember everything else. Whether that helps you or not, that's just how I do it. Okay? So then in this case, we're still doing the same FOIL that you did on the other problem, but we have the addition of the imaginary numbers. So after we do our FOIL, then we're going to have to substitute some things in for the imaginary numbers to get our final solution. So I'm going to rewrite the problem. So I've got 7 plus 13i, and I'm multiplying that by 3 plus 16i. So I'm still doing first, outer, inner, last, because that's how I prefer to do it. So I've got 7 times 3 is 21. And again, I'm pretending you don't know what you're doing, so I'm writing everything out. Then I've got outers, 7 times 16i. And only because I used a calculator and did this earlier, I know that's 112i. Then I've got my 13i times 3. That's going to give me 39i. And then I have my 13i times my 16i. And this is where it gets a little funkity-dunkety. That's going to end up giving me 13 times 16 is negative 200. I'm sorry, is positive 208. But I've got my I times I. So right now, I'm just going to write I squared. Now, This is where you have to kind of get a little bit, what am I supposed to do? We just went over that I squared equals -1. We just talked about that right here. So instead of me writing 208I squared, what I do is I say, okay, I'm going to cancel out this 200, this I squared, and I'm going to write -1. So really, this term is 208 times -1. And so I really know, well, that's just going to be -208. So this right here, I know is -208. Let me do that one more time. Because I have I squared, I know that I squared equals -1. So this is really saying 208 times -1. 208 times -1 is -208. And that takes care of that term. Then I'm going to continue to combine like terms. And if you just signed on and don't know, if you saw on the website, gwinnetmath.com, I have this presentation that we're going through. I have the review sheet that your teachers, I think, already gave to you. Okay, then I'm just going to do my normal combining like terms. I'm going to pretend the I is an X, so the I stays the same. I've got 112 plus 39. That's going to give me 151. And then I've got my 21. Okay. Now I'm going to say, well, I'm not quite done yet. Kim, if you want to just turn off your camera, everyone can see you, which is totally fine with me, but you might want to turn off your camera. You'll see like a little button on the bottom of your screen. Okay, now I'm going to combine. I know I have to put in A plus BI form. All that means is the constant comes first and your imaginary number comes second. That's all that means. So I'm going to take my positive 21 and my negative 208 and put it in my trusty calculator. So I've just got 21 plus negative 208. And I get negative 187. So that's going to be my A. And then my B is just this coming down. And that is the answer. So I know for some of you, I did that too slow, but for some of you, I did it just right. So that's kind of what we're going to do. Let's take another look at a problem. Here it says an expression is shown. What is the value of the imaginary coefficient after you simplify it? Now, what makes this tricky is here, first, we have to solve this piece of it. And we have to solve this piece first because we're squaring part of it. After we square part of it, then we'll add the other components to it. So let's start off by just focusing on the squaring. To square, I've got the -5. This one I'm going to go a little bit faster because it's not the first time. Times 7i. And then I'm going to do -5 like this. I said times 7i. So I've got -5 minus 7i times the quantity -5 minus 7i. I still... Now, this other stuff is still over here. I still have plus -8 minus 4i. That still exists, but for right now, I'm not thinking about it. All right, so now we got to just do our FOIL again. So I'm going to do first -5 times -5. That's going to give me positive 25. Then I'm going to do my outers, which is -5 times -7i, -5 times -7i. Negative times negative is positive, so I've got positive 35, and then my I comes down. Then I do my inners. So I've got my -7i times -5. Negative times negative is positive again, and the I just hangs out. And then I've got my last. So why did that just move? My last is the -7i times -7i. Okay, negative times negative is positive, 49i squared. But again, because we have that 49i squared, we know that I squared is really -1. So now I know I've got positive 49 times -1, which really means this is really -49. This still combines, and the 25 comes down. So now I figured out the negative 5 times 7i, that quantity squared. I've already just figured that out. That's that whole first part. I should, good practice is simplify it one more time. But when you simplify it one more time, 25 minus 49, that's going to give you negative 24. And then we still have the plus 70i. Remember, a plus bi form, so that the constant goes first and the I goes second. Now, after that's like perfectly simplified, I'm now going to come back up here and bring this stuff down. So now I'm going to write plus negative 8 minus 4i. Now, because it says plus, truly, I can just eliminate the parentheses because I'm adding the whole thing. If it was a subtraction, I'd have to distribute that negative like we did in the other problem. Now all I'm going to do is combine like terms. First, I'm going to look at the terms that do not have an I next to them. So I've got negative 24 and negative 8. When I use a calculator, that's going to give me negative 32. And then I look at my i's. I've got positive 70i here, negative 4i here. Using a calculator, that leaves me positive 66i. Okay, so where are we feeling with this? Do we feel like we've got a good handle of this type of conjugates, or do we need to go over it one more time? I have one more conjugate question that we can go over if you... Well, now we're going to do complex conjugates. So are we okay with the simplification? Awesome. Yay, I like yes. Okay, let's move on to your next AKS. Your next AKS is AKS 57. Okay, so this is the one that we're going to look at now. Now, when it comes to conjugates people think are like, wow, that's so hard. Or I heard conjugates when I was in ELA class. All conjugates mean is switch the sign. That's it. So when we start with A plus BI, the conjugate of that is A minus BI. That's it. I don't know why I did the B cursive. BI. If we start with A minus BI, the conjugate is just A plus BI. All we do is we change the sign that's in between the A and the B. That's what conjugate means. Now, the reason why we do it is because just like it's technically correct for you to have, like, this is a side note, we know that it's not good math to have 4 divided by negative 3. We know good math is to either write it as negative 4/3 or to write it as negative 4 over 3. That's the same reason why we need to do conjugates. It's just not good math to have an imaginary number in the denominator. So that's the whole purpose of conjugates. Conjugates have us change the signs so that we can eliminate the imaginary numbers on the bottom. Now, we'll end up having more imaginary numbers on the top, but it allows us to eliminate it from the bottom. So that's why we need it. So let me real quick erase this stuff that we don't need, and then we'll get going. Okay, so it says, what is the complex conjugate of yada, yada, yada. So the first thing before you can do conjugate is you really should turn it into A plus BI form. Remember, all A plus BI form means is that the number goes first and the I comes second. So here, the 13 is going to come first, and whatever touches the I, in this case, negative 3i, comes second. That's what you do. That's standard form. Now that we have it in the proper form, everything stays the same, the exact same, except the sign. 13 becomes 13. 3i becomes 3i. This is negative, now it's positive. And that's it. That's the answer. You're not doing anything at all different than that. Complex has got an imaginary number. Conjugate means you change the sign. Now, the reason why it's important is for like number 2. So in number 2, we have that imaginary number in the bottom, which we're not supposed to have. So because of that, we have to eliminate the imaginary number. The way that we eliminate the imaginary number is to multiply by the conjugate or the opposite. So that means that of whatever the denominator is. So here I've got 3, that stays the same. Here I've got 2i, that stays the same. Now, we have to do it one over the other because it's got to be like you're multiplying by 1. It's kind of like if I have 2x over 3 and I multiply by 3 over 3. Well, 3 over 3 is 1. So all I'm doing is multiplying by 1. That's the whole point of this, is we're multiplying by something that is equal to 1. But because we want to get rid of the imaginary number in the denominator, we have to change the signs. That's going to eliminate the imaginary number in the denominator. So this is positive, so this has to be negative. And because it has to equal 1, whatever I put as my denominator, which is what I always do first, I put the same thing in the numerator. Now, good math is you make it nice and pretty and you go all the way across. I'm not going to do good math. I'm going to do how I like to do it. I always, on a separate side of the paper, figure out the denominator first because it makes me less stressful. So I will first just write down somewhere on my piece of paper, okay, what is 3 plus 2i times 3 minus 2i? That's my denominator. So then I just do normal FOIL. 3 times 3 is 9. 3 times negative 2i, 3 times negative 2 is negative 6, and then the I hangs out. 2 times 3, positive 2 times positive 3 is positive 6i. Positive 2 times negative 2 is negative 4, and then I'm left with my I squared. I always do the denominator first because this makes sure my conjugate's correct. Because look what happens. First, I just have that 9 floating. Great, nice to meet you, 9. Now I've got negative 6 plus 6, which is 0. My I is gone. I'm left with I squared here, but we learned on the last slide that I squared doesn't exist. It's really negative 1. So this section is really negative 4 times negative 1, which I got because I squared is negative 1. So all I did is I substituted negative 1 in for I squared, and I got positive 4. So I know my denominator is 13. I have no i's left. So I did this problem correctly. So this is going to equal 13 in my denominator. Now that I know the denominator is correct and I picked the correct conjugate, now I can do the numerator, and I know there's going to be i's in it, but it's totally fine. I'm allowed to have i's. The goal is to get the i's, or the imaginary numbers, out of the denominator. So now what I'm going to do is come here, and then I'm just going to do my numerator, which is 2 minus 15i, 3 minus 2i. And then I do my normal multiplication. 2 times 3 is 6. 2 times negative 2 is negative 4i. Negative 15 times positive 3 is negative 45i. I'm just making sure I did this correctly. Yep, I did. And then a negative times a negative is positive. And then I've got my I squared. Now I do my substituting. I know that first, this is going to combine negative 4 plus negative 45 on my calculator is negative 49, and my I just hangs out. It's just like an X. Here, though, I have I squared, so it's not like an X squared. I know that I squared is really equal to negative 1. So I've got my 30 times negative 1, which is negative 30. Now I combine my like terms again, and I think about what's A plus B I form. So I know I've got to put my coefficients or my constants first. So I've got 6 and negative 30. When I combine those together, that's going to give me negative 24. And then the negative 49 just hangs out. So now all of that work was my numerator. So I'm just going to put up here negative 24 minus 49i, and then I am done. So obviously when you do this, you're going to go a lot faster. But I'm teaching this like you've never ever seen it before because I want to make sure that you get it. One other thing I just realized we didn't do is here, we never answer the question. So the question was, back to this other problem, is what's the value of the imaginary coefficient? So the value of the imaginary coefficient, I should write nicer than that, is just 66. Okay, I forgot to tell you that part. All right, so that is how we do complex conjugate. Does anyone need me to do another example of complex conjugate? Okay. Oh, I see yeses. Okay, perfect. Let's do another example. I don't have one handy, so let me look real quick and let's find one online. Let's see. Well, that's too easy, but let me put this one in. And let's find one more, and then I'll show you how to do it. Let me go to images and see if there's a division problem we can look at. There is. Move my head. Okay, so let's look at this one more time. So I've got two things going on. First of all, looking at complex conjugate one more time. Thank you for telling me you need help. That's the whole point of this. Okay. Oh, someone asked, where'd you get negative 24 from? Ooh, why didn't that come through? Sorry, Amari. Okay, let's go back real quick. I got negative 24 because when you have 6 minus 30. So all I did is I combined those pink terms. I don't know why I didn't get that notification earlier. So here's 6, here's negative 30. So I combined those. And I got negative 30 because from right here and right here. So I just took, I knew positive 30 times negative 1 is negative 30. And then all I did is I just did 6 minus 30, and that's how we got the negative 24. And I had to do that first because I needed to put it in A plus BI form, which means that A has to come first. So the numbers have to go first. So I had to do 6. Oh, from composite functions. All right, Amari, we'll get back to that later. Let me see real quick. On this page, where are we looking? Or is it a... All right, I will have my chat open so I can see it more easily. I'm sorry I missed that one. All right, let's keep going. So back to here. So let's do it again. So we're pretty much going to, again, start off. The basic thing is all you do is switch the sign. So how this says A plus 5i, it's already in A plus bi form, where 8 is my A and 5 is my B. So it's already in the right form. In order to get my complex conjugate, everything stays the same except the sign. So how this started as positive, now it's negative. And that's my complex conjugate. Done. Okay? How we use the complex conjugate is when we do division. So here, I'm left with, okay, it wants what's 3 plus 4i divided by 8 minus 2i. So because I need to get rid of the imaginary number, this is when the complex conjugate comes into place. I know that my 8 is going to end up staying the same, and I know my 2i is going to stay the same. That never changes. So same thing here. This was 8 and 5i. Here's my 5i, here's my 8. That does not change. So here's my 8 here, here's my 8 here. Here's my 2i here, here's my 2i here. The only thing that ends up changing is the sign. That was negative, or positive, now it's negative. In our problem, this is negative, so that means right here, I'm going to be writing a positive. But because I'm doing this and I'm multiplying, I have to make sure that I multiply by the same for the numerator and the denominator. So because I have 8 plus 2i in the denominator, to get rid of the imaginary number, I need to put 8 plus 2i in the numerator. So up here, I'm going to write 8 plus 2i. And that's just because this makes it equal to 1. I literally could also put 7 over 7 because 7 over 7 is 1. That's why you have to do the same. Now, my practice is I always multiply the denominators first to make sure my conjugate is correct. Because if I multiply my binomials for my denominator and I get the same information or the same pieces, then what's going to happen is it's going to allow me to know that I picked the right thing. So real quick, I think we're going to show you something a little different. I'm going to move this down here. Okay, so now what's going to happen is I'm just going to do my normal multiplication. So I've got 8 times negative 2i, 8 times positive 2i. Then I do my first, outer, inner, last. 8 times 8, or I'm not going to confuse you. I don't want to confuse you. 8 times 8 is 64. 8 times 2i, 8 times positive 2i, 8 times 2 is 16, so I've got positive 16i. Negative 2 times 8i for my inners is going to give me negative 16i, which right now, yes, that's what I want because I know 16 minus 16 is 0. That's what I was going for. And then here I've got negative 2i times positive 2i. Well, a negative 2 times positive 2 is going to leave me negative 4. And then I know I'm going to have I squared. But what does I squared really equal? I squared really equals negative 1. So I'm just going to make this say negative 1. So again, my goal is I have to simplify my denominator. Now I combine like terms. So I've got my 16 minus 16. This cancels out. That's 0. So I'm left with 64 here. Negative 4 times negative 1 is positive 4 because a negative times a negative is positive. So I know that my denominator equals 68. And I have no imaginary numbers. So because I have no imaginary numbers, I know that I picked the correct conjugate so that I can continue working on my numerator. For my numerator, it's the same process. I've got 3 plus 4i times 8 plus 2i. So I'm going to start by doing my first. 3 times 8 is 24. Then I do my outside. 3 times 2i, 3 times 2 is 6, and then the I just hangs out. Inside, positive 4i, positive 8, positive 32i. Last, positive 4i, positive 2i, that's going to give me 8. It's really going to give me 8i squared, but I know that I squared is negative 1, so this is really going to give me 8 times negative 1. Now I simplify. I've got my 24. That's just going to hang out right here. Then what I'm going to do is, oops. So here's my 24. I'm going to combine these like terms. 6 plus 32 is going to give me 38i. And then 8 times negative 1 is going to give me negative 8. I'm not done yet because I still got to get it in the a plus bi form. So I'm going to combine everything that's not connecting to an I. So now I'm going to combine 24 plus negative 8. So in a calculator, 24 minus 8 is going to give you 16. And then you have your 38i. Now, what's a little not fun about this problem is all the numbers are even. So if I'm going to do this problem the really, really correct way, I now need to divide everything by 2. I was seeing if I had to divide by 4, but 4 won't go into 38. So then to really do this problem correctly is I have to say, well, all of my numbers are even, so I'm going to divide everything by 2 so I can simplify it even more. So 16 divided by 2 is going to leave me with 8. 38 divided by 2 is going to leave me with 19i. And 68 divided by 2 is going to leave me with 34. So now my final answer to this problem is 8 plus 19i divided by 34. Okay, thoughts, move on, stay, what do we need to do? Move on. Awesome. Next one, let's look at this one. Perfect. AKS 45. Excellent. If you need help, you can come let me know, or you can send me a message on Instagram and I will do my best. Except somehow I turned off Instagram notifications, so I don't always see the message right away. But you can do that. I check it twice a day. All right, we're moving on to AKS 45. AKS 45, again, is the one where you have to compose functions and find the inverses. Okay. There might be an easier way. I know I almost always give you ERIC hacks. I cannot figure out an ERIC hack for this one. So I will do the best that I can do and how I did the problem when I solved it last night. So, or technically when I solved it at 6 a.m. this morning. So I'm going to use the highlight tool to kind of show you what I was thinking when I went through it. And I'm going to use the think aloud strategy. But there might be a way easier way to do it, but this is the only way I know how to do these problems. Okay. The weekly cost of producing the new iPhone 11 is a manufacturing process. In a manufacturing process is written by the function C of X. So for me right away, I know that C of X is going to be important. C of X. The cost is, so I'm going to put is, given by $850 as the base and $60 per iPhone. So that's one sentence in one thought. So I'm going to change my colors. Then it says there are 5 iPhones that are created per hour T. And it tells me the function is X of T. So this is the only way I can think of to do this problem. What it wants us to do is write the functions. So I kind of coded mine so to help you kind of get the idea. The first function I need to do is C of X. Well, C of X is, anytime you see the word is, it means equals. So I've got the function C of X, or the cost per X. And X is, for me, I wrote down X equals the iPhone because it just helped me follow along to what I was doing. And actually, let me give myself more space. So I know X equals the iPhone 10 or iPhone 11. So I know that the cost of every iPhone, so C of X is really the cost of an iPhone, is $850 and plus $60 per multiply iPhone X. So let me write that out a little bit differently. So here we know that C of X equals the cost. $850 represents money. So if you think about it, cost stands for money. $850 is money. Okay, this is the base, the money for the base. The $60 represents the money per, and the X represents the phone. So that's how I had to write the equation. There might be a better way, but I just have to do it that way. All right, then when I go on to my next equation, which I'll write in green, this time I know that T stands for hour. So for me, I wrote T equals hour. And then it tells me the function is X of T. So I know X is in relationship to T. It means like how many X's, X is phone. So how many phones per hour? That's what I'm looking at. How many phones per hour? Then that has to equal is 5 iPhones per hour T. And again, this represents the number of phones, and this represents the hour. So first of all, I start off by just writing my equations by taking the time. So some things to remember if you don't remember is means equal. So anytime you see is, you're thinking equal. Anytime you see per, you're going to think of multiply. It's the best way to say it. So if it says is, you're going to write an equal sign. If it says per, you're going to multiply. So now that I have my 2 equations set, now it wants me to do the composition of it, which means it wants me to take your C, and it tells me it wants C of X. Well, that really means it wants you to take your C, and instead of writing X, it wants you to write X of T inside of it. That's what it wants you to do. So what I did is I said, okay, well, here's my C, and I'm taking x of t, oops, doot, doot, and I'm plugging it in every time I see x. So that means that this equation right here that I just did, 5t, I'm going to put in every time I see x. So every time I see this, I'm writing in 5t. So I'm going to go back up here, change my color. So that means that my 850 stays the same. That doesn't change because there's no x next to it. My 60 stays the same, but instead of writing x, I'm going to write 5t. And so again, this is saying the cost equals $850 plus $60 per phone that I make. It wants to know what's the cost of doing this for how many phones you can make per hour. That's the difference. That's what I'm working on. So now I just have to simplify my math. So I'm left with this C of x of t equals 850 plus 300t. And remember, this first equation is about money. So really, this is saying that my total cost is $850 plus $300 per hour. And remember, if it's multiplying, it means per. So basically, all I did is I took this equation, I figured out how many phones could I do per hour, and I substituted how many phones I could do per hour into the cost equation. So this is telling me the total cost per hour is $850 plus $300 per hour that they're making phones. I have no other way to make it more simple than that. I'm so sorry. Let's look at another one. So, oops, I have to post another one. Okay, so this next one that hopefully you guys have the review sheet for is asking us for gallons and barrels of gasoline. So according to the U.S. Energy Information Center, administration, a barrel of crude oil produces, so right away, I'm just going to start highlighting things in one sentence. So I've got a barrel of crude oil produces 20 gallons of gasoline. That's one thought, one sentence. Then it tells me that the Honda Accord does 47 miles per gallon of gasoline. It tells me that G of X, so I'm going to switch back to green, stands for gallons by X barrels. So I know X, the barrels, is going to be my variable. And then it tells me that M of G is going to be miles that of gallons, G gallons it can drive. So then we have to write our equations. So I know, I'm sorry, I wish this was easier. There's no other way to do it that I can think of. So first of all, let's write our equations. We know that X has to equal the number of barrels. Then it tells us that G of X is 20 gallons of gasoline per multiply barrel. So if I have 10 barrels of crude oil, I'm going to do 20 times 10, and I have 200 gallons of gasoline. So this is the barrels of crude oil. Then for my next equation, it tells me that G has to stand for how many gallons of gas. So then it tells me M of G has to be 47 miles that I can drive per gallon of gas. So just like I did for the other problem, let's look at this one more time a little bit deeper. This is how many gallons of gas that I need. This is 20 per the number of barrels. This stands for how many miles I can get on 1 gallon. This is 47 total gallons, or sugar shoots, miles, per 1 gallon. So now I have my equations. Now it wants me to interpret, what does m of g of x equal? So I'm going to start off by writing my m equation. So one more time, my m equation is m of g equals 47g. But instead of me writing 47g, I'm going to write 20x. So that means that really my equation is m of g of x is going to equal 47 times my 20x. Now I have to do the math. 47 times 20 on a calculator, because I did this morning, is 940. But that's not what it's asking. It's asking, what does that mean? What does the 940 mean? Well, I know that m stands for miles. So I know it's got to be something to do with miles. And I know x stands for barrels. So basically what this equation is saying is, here I know that this has to stand for miles. And I know it stands for miles because here is my m. And I know m stands for miles. X stands for barrels. And I know that x stands for barrels because that's what I said when I started my problem. So m of g of x means that on the Honda Accord, a person can drive 940 miles per barrel of crude oil. And I don't want to say that's it, but that's it. But it took a long way to get there. Now, part of the reason why it took a long way is because I explained everything step by step. But that is the best thought that I can have on how to do that problem. Okay? Does anyone need me to do one more? I don't have one more. We can look for one more if we need to. I think if you just watch it one more time slowly, you should get it between those two. So I'd prefer to move on if that's okay. All right, I'm going to move on. All right, next is inverses, because we have a lot that we need to cover. So, and I want to try to get done by 1:30 for you. Inverses to me are relatively simple in the sense that all we're going to be doing is changing the x and the y. So here we've got find the inverse of these three different equations. Okay, so first things first, I'm going to write it a little bit more easily. So here I'm going to write down that. Why are you not writing, kid? Okay. Oh my gosh, what happened all of a sudden? Okay. First, I'm going to write it down just as y equals. So this is really saying y equals -3/4 x plus 2. Anytime you do inverse, you switch the x and y. So instead of writing y equals blah, 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 I'm going to write x equals blah, 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 y, blah. Okay? What does that mean? Well, it means x equals, instead of the y, I still keep my -3/4, but instead of writing x, I'm going to write y plus 2. And now I solve for y. So the way that I solve for y is I'm trying to isolate the variable. So I'm going to subtract 2 from both sides. So I've got x minus 2 equals -3/4 times y. Now the way to eliminate -3/4 is to multiply by the reciprocal. So instead of multiplying by the reciprocal, whatever I do to one side, so here if I multiply by -4/3, the negatives would cancel, the 4's cancel, and the 3 cancels. So that's why you multiply by the reciprocal. So if I multiply by that reciprocal here, I have to multiply by -4/3 here. Whenever we multiply by a fraction in a binomial, the quick way to do it is just the denominator is whatever you multiplied by. So because I multiplied by -4/3, I can just throw the 3 in the denominator and be set because I'm multiplying by, in essence, a whole number. Now, x minus 2 isn't a whole number yet, but in theory, we can assume it's a whole number. And then that means in the numerator, I'm going to be left with -4 times x minus 2 to equal my y. When I simplify, -4 times x is -4x. -4 times -2 is +8 divided by 3. Is that what I got the last time? It is, equals y. So that's the first one. That's number 5. Okay. Number 6 is similar. So let's look at number 6 over here. Number 6 is we've got y equals 4 over x plus 2, and all of that is plus 1. So what I did is I first was like, all right, let me get the y to the other side. I'm sorry, let me get the 1 to the other side. So I subtracted 1 from both sides. Wait, is that what I did? Yep, I think that's what I did. So I have y minus 1 equals 4 over x plus 2. Okay, now this is a little bit tricky. We're going to write this out like we're going to multiply binomials, but we're really not going to be multiplying binomials. We're just going to write it that way so we can cancel things out. So what I mean by that is on one side we have the y minus 1, and on the other side we have the x plus 2. I need to multiply this by x plus 2 over 1 so that my x plus 2's can cancel. So this side, I'm left with 4. On this side, I'm going to multiply it by x plus 2. But I'm going to be a little bit sneaky. I'm not really going to, hold on. I wrote something different. What did I write differently? Plus 1x. I wrote y plus 2 for something. What did I do wrong? Hold on. I'm going to restart that problem because I either did it wrong this morning or I'm doing it wrong right now. So let's restart that problem because I don't want to completely confuse us even more. This is when I growth mindset told you I have not done algebra in a while. So let's try this one more time. Okay, I have my apologies. And when I upload this video, I'll take out the wrong part so no one else gets confused. But since you're live, you get to get confused with me. Okay, so we're left with y equals 4 over x plus 2 plus 1. That's what I forgot to do. I forgot to switch the x and the y. So here I'm going to put x equals 4 over y plus 2 plus 1. That's what I forgot to do. I forgot to switch the x and the y before I tried to solve it. So now I'm still going to subtract 1 from both sides. That's going to leave me with x minus 1 on this side and y plus 2 on this side. Okay? Again, we're still trying to isolate the variable and get y by itself. Now I'm going to do the multiplication thing that I told you about. I'm going to multiply this side by y plus 2, and that will allow me to cancel the y plus 2 from the denominator. So I'm left with, on this side, 4. On this side, I'm also going to multiply by y plus 2, but I'm not going to do anything fancy. I'm not going to do the math for it. I'm just going to leave it as y plus 2 times x minus 1. Okay. Now, because I'm trying to get the y plus 2 by itself, I'm going to divide both sides by x minus 1. And when I do that, what that's going to allow me to do is to cancel these out, so I'm left with y by itself and not in a fraction. And whatever you do to one side, you do to the other side. But now I still have the plus 2, so I have to get rid of the plus 2. So now I'm going to switch and make both sides. I'm going to subtract 2. So my final answer is y equals 4 over x minus 1, and all of that is minus 2, which is what I got this morning. Okay, so to summarize, what I did wrong the first time and we learned from is you need to, after you make your equation, make sure you switch your x and y. Then what I did is as I went down, I solved it. So on this step, I was like, okay, now that I've switched my x and y, then what I need to do is I need to solve and get y by itself. So first I moved the 1 over so I could have the y plus 2 on the bottom. Then I multiplied both sides by y plus 2 so I could get rid of the y in the denominator, but that left me two variables on the left-hand side. So then I divided both sides by the x binomial so I could just get the y binomial by itself. And then after I had my ugly fraction, I still had to subtract the 2 so I could get y isolated and completely by itself. Okay, that hurt my brain. That was a good growth mindset question. All right, next one. Way easier. Here we have y equals 9x squared plus 4. Switch the variables. So I've got x equals 9y squared plus 4. And I know this video is going long, so if you need to go, you can go. I'm still going to keep recording, and then I'll upload it. You can always watch it later. I'm trying to isolate the variable, get y by itself, so I'm going to subtract 4 from both sides. Divide both sides by 9 to get y by itself. And then I have to take the square root. So I'm going to take the square root of this side, take the square root of this side. So I'm left with the square root of x minus 4. And then I know that the square root of 9 is 3. So then I'm left with this. And this is my final answer, which is what I got the first time. Okay, so that was way easier than the last one. Okay, moving on. We only have 5 questions left, and then we're done. Okay. Next one, Miss Kingery, who is obviously a math teacher at South, wrong button, is going to put new carpet in her classroom. She measures the wall, and transparently, this is one of the questions where I'm like, I don't exactly know what your teacher wants. So I wrote on a note, see your teacher for the rest of it, because I can't figure out what else to do after what I'm going to show you. She says the classroom is a perfect rectangle and the area of the carpet is 5x squared minus 23x plus 12. And what's the dimensions of the carpet? I'm assuming we're keeping the dimensions of the carpet in terms of x, because that's the only way I know how to do it. The fact that she says it's a perfect rectangle, I think, is only so that they know that area equals length times width and that you know you have to multiply two things together. What we need to do is we need to figure this out. I'm going to show you the box method way of doing this. So we have 5x squared minus 23x plus 12. The box method, which some of your teachers taught you in Algebra 1, is you're trying to figure out what goes on the top and the sides. So I know that 5x squared has to go here. And I know 12 has to go here. I'm trying to determine what values are going to go here that are going to give me the sum of 23 and also are multiples of 12. Well, for all intents and purposes, I typically, because 5 is a prime number, I would just put 5x here and x here, because I know that 5x times x is going to give me 5x squared. Also, I know that whatever number goes here is going to have to be a multiple of 5 because 5 has to go into it. In order for me to get 12, I can do 1 times 12, 3 times 4, and 6 times 2. Because this is a positive value, I know that both of these signs are either going to be both be positive or both be negative. Because this is a negative, I know both of these signs are going to be negative, which means these numbers here are going to have to be negative. And a negative times a negative is a positive. That's another way to check. So if I do 1 here, and then 12 up here, that's going to give me 17 because 1 times 5 is 5. 5 plus 12 is 17. That's not going to work. If I put the 12 down here, 12 times 5 is 60, which is going to be way more than 23, so that's not going to work. This combination won't work. Now I'm left with 3 and 4. And if I put the 3 here, 3 times 5 is 15. This is going to be 4. That's only going to give me 19, which is not going to work. If I put the 4 here, 4 times 5 is 20. That means the 3 would go here. 3 times 1 is 3. And then that would leave me with the 23 that I need. So when I combine terms, I've got, or I don't have to combine terms, I'm working backwards. So now that I've factored it, I know my dimensions are 5x minus 3 and x minus 4. This is as far as I know how to get. So on this particular problem, if you have your review sheet, you're going to have to see your teacher because I don't know what else to do past this point because there's not another metric. But that is as far as I can take you that the dimensions are 5x minus 3 and x minus 4. What the value of x is, I have no idea. But that is as far as I can take you on that one. Okay, next set of questions is we're going to be solving by a method of our choice 3 types of equations. And then explaining why we chose that particular method. Okay, so first I'm going to simplify. That seems to work best for me. So I'm going to start off by just simplifying this. So I've got 3x minus 10x plus 20 equals 6x. So when I simplify, I'm just going to subtract 6x from both sides. This cancels and leaves me 0. So now this is going to allow me to factor. So I'm left with 3x, this should be squared, minus 16x plus 20 equals 0. And now that I've done that, I can, I'm going to use the reverse FOIL method. So I've got 3x here. I know this is x. I know I'm trying to get 16. This is a positive 20, so I know both of these numbers are going to be negative. And then I'm trying to get 16, so I know I'm not going to put 20 here because 20 times 3 is 60. So it's not going to be 20 and 1. 2 and 10, if I put 2 here and 10 here. Oh, that is I wasn't even expecting it. So I put 2 here. 2 times 3 is negative 6. And that means 10 would have to go here because negative 10 times negative 2 is positive 20. And that would give me negative 10, which gives me negative 16. So those are my 2 binomials. Because this equals 0, we're going to have to set each one of these equal to 0 to solve. So I'm going to add 10 to both sides. This one I'm going fast because you should remember this already. Divide both sides. So on this side, I'm left with 10/3. And then on this side, add 2 to both sides. And you have x equals positive 2. So these are your solutions to the first one. The next one, and the reason why we did factoring is because it was a trinomial. So because it's a trinomial, the other methods don't make a whole lot of sense. Here, we're going to add 81 to both sides. Sugar shoots. We're not adding 81. We're going to subtract 81 from both sides because we have to do the inverse operation. So that's going to have this cancel. We're going to be left with x squared equals negative 81. Then we have to take the square root. Back in the day, we told you could never, ever, ever take the square root of a negative number, but we lied to you until you got to Algebra 2. You know that you can take the square root. You just have to make sure that you put an I. The square root of 81 is 9. And you have also learned that because you are taking the square root, positive 9 times positive 9 is 81, and negative 9 times negative 9 is also 81. So that's why you have to put plus or minus 9i. That's that question. Next question, you could literally just do it the same way I did it. But I think what they want you to do is notice that this is a difference of 2 squares. So we're going to put x here equals 0. Because it's a difference of 2 squares, because we know the square root of x squared is x, and we know that the square root of 64 is 8. That's why we put this here and here. Set each of them equal to 0, and you get x equals negative 8, and x equals positive 8. And then, to make it pretty, plus or minus 8. Okay, that's the factoring questions. Next. All right, this next questions have to deal with using the discriminant and finding the solutions using the quadratic formula. Now, whenever I teach this, make my students sing the quadratic formula because they used to not be able to be given the formula on the formula sheet. But in Algebra 2, you do get the formula sheet. Couple things real quick. The formula is, I sing it to row, row, row your boat. It is x equals opposite of b plus or minus radical b squared minus 4ac all over 2a. Yay. Okay, so the discriminant, if you don't remember, all it is the stuff that's underneath the radical. That's it. So in this case, because we need the solutions and we need the discriminant, we're just going to do the whole formula. And then we're going to take a peek at the discriminant as we plug in the formula. So that way we know how many solutions we're looking for. All right, here comes our first one. The first one is, let's first make it equal to 1. So we've got, equal to 0. So we've got 2x squared plus 4x. And then I'm going to do the inverse operation to negative 1, which means I'm going to add 1 to both sides. This leaves me with a equals 2, b equals 4, and c equals positive 1. Now I just use the formula. X equals the opposite of b plus or minus radical b squared minus 4 times AC, 2 times 1 is 2, all over 2a. And then I simplify, and I normally simplify whenever I do quadratic formula, I simplify above and below. So here I've got negative 4 plus or minus the square root of 4 squared is 16, minus 8 is positive 8, and that's going to be divided by 4. Now I'm going to stop here for 1 second because it wanted to know about the discriminant. Because the discriminant is 8, a couple things. If your discriminant is positive, you're going to have 2 real roots. If your discriminant is a positive perfect square, you're going to end up having 2 rational roots. If your discriminant is a positive number that's not a perfect square, then you're going to have 2 irrational roots. If your discriminant equals 0, you're going to have 1 real root. If your discriminant is less than 1, then you're going to get into imaginary roots. Okay, so here, because it's 8, I know my roots are going to be real, and because you can't take the square root of 8, it's going to give you a radical. I know that in this case, my roots are going to be irrational. Because of the 8. Okay, hold on. Next. Okay, so now I just continue to simplify. So this, the square root of 8 is really 2 square roots of 2. So I'm left with negative 4 plus or minus 2 square roots of 2 divided by 4. I'm going to simplify everything by 2. So I'm left with negative 2 plus or minus the square root of 2 over 2. And I can't simplify that anymore because there's no coefficient in front of the radical 2. I have to leave the radical 2 as it is. Okay, next one, let's look here. Here we've got our 2x squared. I'm going to add 4x to both sides. Equals 0. That gives me a equals 2, b equals 4, and c equals positive 3. Now let's solve it. We've got x equals the opposite of b plus or minus radical b squared, I'm just going to write the 16, minus 4 times a times c is 6, all over 2 times 2 is 4. Now I'm going to rewrite it. I've got negative 4 plus or minus 16 minus 24 is going to give me negative 8. And then still everything over 4. Now I'm going to look at this negative 8 because we got to do the discriminant. Because it's negative, I know that I'm going to have 2 imaginary roots. Technically 2 irrational imaginary roots. And then I just continue to simplify it. This is going to still be the negative 4 plus or minus. This will be 2i square roots of 2. So when I do my final simplification, I know this is long. You guys just have so much that she sent me for you to cover. But we're almost done. We're nearing the end. Now I still simplify by 2. So my final answer for the second problem is plus or minus I square roots of 2 over 2. That's that second problem. And then the last problem is way, way easier. A is 2, B is 4, C is 2. Opposite of b, negative 4 plus or minus radical. B squared is 16 minus 4 times 4 is 16. All over 2a, which is 4. Again, let's look at the, sugar shoots. Let's look at the discriminant here. 16 minus 16 is really the square root of 0. So because we have the square root of 0, we know that we're going to have 1 real root. And that's because the square root of 0 is 0. So really, we're just left with negative 4 divided by 4, which when we simplify it, we get -1. Okay, last three problems. AKS 43. Now, in all transparency, I have not done these two problems yet, so we'll be doing them for the first time together right now. And then we will hopefully stop by 40 so I can get ready for geometry. Next. Okay, Snelling Dining Group owns 2 separate restaurants, Dominic's Italian Kitchen and McCrary's Tavern in Lawrenceville. Sales for each restaurant has been calculated over the past 5 years. Dominic's Italian Kitchen has sales over the last 5 years represented by the function. McCrary's has sales over the last... I think this might be a typo. I don't know how to do it. I'm 99% sure that is not possible. So we're going to move that one on. Let's look at division, because it doesn't tell us anything at all for us to write anything down. Division, here we go. Whenever we do division, first we need to make sure that we have all the terms. Here we do 3, 2, 1, 0. All of the terms are there. I'm going to do this with synthetic division. And just because it's been a long time, I want to pull up one example of synthetic division so I don't steer you wrong. Okay. First things first, because this says x minus 3, I'm going to have to set that equal to 0 so I can find out what number I'm really going to be using. So I'm going to add 3 to both sides. So I know that x has to equal 3. So when I set up my synthetic division problem, I have to make sure I have a positive 3 out there. Then I'm going to list all of my coefficients in order. So I'm going to put a 2 here, a -3 here, a -13 here, and a positive 12 here. Again, all I did is I changed this sign from negative to positive. And then I followed along by writing my coefficients. This is -3, this is -3. So you do need to pay attention to what the signs are. Okay. Next, what we're going to do is you first bring down the first number. So I'm going to bring down the 2. That always comes first. Then you're going to multiply 3 times the 2. So 3 times 2 is 6. Then you just add going down. -3 plus 6 is positive 3. Now what I'm going to do is, so I've got my -3 times 2 gives me this number. Now I'm going to do 3 times 3, and that's going to give me the magenta number. So 3 times positive 3 is positive 9. Add going down, -13 plus positive 9 is -4. Now I'm going to take that -4, multiply it by the 3, and that's going to give me my final number, which is -12. Add going down, and I get my 0. Whatever you get at the end is your remainder, always. In this case, I have no remainder. Yay! Then you always go backwards. So this is the constant. This is going to have your x. This is going to be your x squared. So your answer is 2x squared plus 3x minus 4. And that's it. Let's look at another problem. Let's say we have, because I know some teachers did not necessarily teach this the same way. So let's say, let me get a hard problem. Okay. Nope. Yep. Okay, let's say we have 2x cubed minus 3x squared plus 4x plus 5. And all of that is divided by x plus 2. What we're going to do is first, we're going to figure out what x plus 2 equals to get our plane x. Then we're going to make sure all of our coefficients go down in order. 3, 2, 1, 0. They do. Then we're going to draw our line and write our coefficients. 2, -3, +4, 5, and this -2 is going out for a ride. So we've got this. This one goes here. This one goes here. I'm just getting my color coding done first. This one goes here. And then this last number is going to be my remainder. So now we do the math. First, whatever this number is, it comes straight down. This is 2. This comes down. -2 times +2 is -4. Add going down. -3 plus -4 is -7. -2 times -7 is +14. Add going down. 4 plus 14 is 18. -2 times +18 is -36. Add going down. -31. The last box is always the remainder. So now I've got, this is my remainder. So I'm going to just put over here -31 divided by, I wasn't dividing by -2, I was dividing by x plus 2. So all I did is I took this, what I was dividing by, and put it down here. Then I work backwards. 18 doesn't have anything. This will have an x. This will have an x squared. So my answer is 2x squared minus 7x plus 18 plus, technically minus 31. Okay. And that's it. That's synthetic division. All right, let's look at one more problem that they gave you here. Her last problem that she had was this one. Actually, in terms of time, I have to stop. So, yeah, I'm sorry. I won't have enough time to get ready for geometry. So I'm going to stop here. I think I have everything done except for 2 questions that she gave you. I am going to stop the video so it can start rendering for everyone else. If you have any questions, please feel free to stop by. Please share the video. And I'm sorry, I didn't realize it was 1:40 and I have my next session to get ready for geometry, which is at 2. So I will see you guys later. Thank you for signing on. Thank you for spending part of your Saturday with me, and ciao.